Hello again. All right. So let's solve another one of these problems to make things a little bit clearer in terms of math. On page 36, problem number 2-26, there's a problem that says, what is the potential difference when 1.25 joules of energy is developed by a flow of 8.2 times 10 to the 17 electrons? It's a lot of electrons, whole lot. A trillion is times 10 to the 12th, right? As we saw in the previous video. And if you take a look on page 32 of your book, you'll see our formula that we actually use to relate potential difference, which is measured in volts, where it relates potential difference with work and charge. How do we know we're working in charge? Well, we don't exactly at the moment, but the formula asks for potential difference, and they give us a value for work, energy, okay? Joules of energy, which is W, okay? Measured in joules. So the closest formula that we have that relates those two is that one that I told you. And it gives us a number of electrons. What do we know about what happens when electrons move? It creates a current, right? What else? We know that electrons also have a charge. So there is a charge associated with this number of electrons. So because it has a charge, we have a value for Q. We just have to get that value from that number of electrons. So here's how we do it. Volts, potential difference, is equal to energy divided by charge. Okay? That's that formula. Q is measured in charge, coulombs. And we see from the book, 1 coulomb is equal to 6.24 times 10 to the 18 electrons. Okay? And we saw from a previous video that I solved that 1 electron is equal to 1.602 times 10 to the negative 19 coulombs. That's for 1 electron. 1 electron contains that value for charge. Okay? So, we have to basically say, take that 1 charge, multiply it by the number of electrons we have. So 8.2 times 10 to the 17 electrons. Okay? When we do that, we get 0.13 coulombs, keeping our value for significant figures down to 2. Okay? So, because that was the number that we were given, 8.2 times 10 to the 17 electrons. So now, work, which is measured in joules, we will put it in our formula here. 1.25 joules divided by 0.13 coulombs. You divide those two, put them in your calculator, you get 9.5 volts, okay? 9.5 volts, all right? Not a huge number, or a really reasonable number when you talk about the value for energy that you have, okay? All right, thank you very much, and look forward to future videos.